Hello everyone, and welcome to the lecture presentation on coded UI testing. I am Mohammed Sharfuddin Shawon from Team 7. Today I and my teammates Bunyod, Eric and Josh will try to introduce you to the concept of code UI testing. We will talk about what code UI testing is, what its benefits are, what are some of the different types of code UI testing techniques, and some of the tools that are used to perform the tests. And at the end, we will talk about some of the challenges and what are some best practices when it comes to performing UI testing. So, without further ado, let's take a look at today's learning objectives. To begin the lecture, I will introduce the concept of code UI testing and try to give you a high-level idea of what it is. Then Bunyod will talk about the benefits of code UI testing and also the different types of testing techniques. Then Eric will introduce you to some of the most commonly used tools and talk about the best practices to keep in mind when performing UI testing. Finally, Josh will talk about some of the challenges we may face when testing UI and conclude the lecture. In today's software development landscape, ensuring that applications are functional, reliable, and user-friendly is essential. This is where Code UI tests comes in. Code UI tests or user interface test, in other words, includes testing the graphical user interface of a software to ensure that it meets the intended specifications and functions correctly. In this presentation, we will provide you an in-depth overview of what code UI testing is, its benefits, and the challenges involved. Again, I will give you a high-level idea of the concept, and my teammates will get into the details later on in the lecture. First, let's start with an overview of code UI testing. This type of testing is conducted to ensure that the application's user interface functions as intended and the complete application meets the requirements. It involves simulating user interactions such as clicking a button, entering text into the fields, navigating through the application. So overall, code UI testing covers everything that the user will have to interfere with the software. So it basically contains everything in the graphical user interface. The goal of code UI testing is to identify any issues in the interface, such as incorrect layouts, broken links, or maybe even missing functionalities. By testing the user interface, developers can ensure that the application functions correctly and it meets the user's need. Because if the completed software is not laid out according to the specified requirements, it might not pass the quality test, or if it has some of the important links are broken, then the software might not function properly, or the user might not be able to navigate to an important function because the link that takes to the page of that function might not be linked correctly. Or it can even, as I said, it could be a missing functionality as well. In that case, a required function of the software can be totally missing, and all of that affects the quality of a software and whether or not it meets the specified quality requirements. Now let's talk about types of UI testing. There are different types of coded UI testing or user interface testing that includes manual testing and automated testing. Now, as the name suggests, manual testing involves a human tester to manually navigate through the application and testing its user interface. When it comes to testing a software, the tester has to go through each and every single functionality, each and every single text field and buttons and whatever is on the user interface. And this type of testing can be very time consuming. But on the other side, it can also uncover issues that may have been missed by automated testing. Excuse me. Automated testing, on the other hand, involves using software tools to automate the testing process. This can include tools such as Selenium, Appium, and Test Complete. Automated testing is faster, of course, and more reliable than manual testing, and can be performed repeatedly with little to no human intervention. While this makes it an excellent choice for applications that are regularly updated or have a high degree of complexity, but it can also miss some critical or non-critical issues in the software that a human tester could have encountered. We will learn more about that later in the lecture. Now, let's move on to the benefits of code UI testing. One of the primary benefits is that it helps ensure the quality of the application. User interface testing can uncover issues that may not be apparent through other testing methods, such as functional testing. It can identify issues related to usability, design, and basically overall user experience. Another key benefit of code UI testing is that it helps reduce the risk of bugs and errors. By identifying issues before the application is released, developers can ensure that the user experience is smooth and seamless. This can improve customer satisfaction, and it can also drastically reduce the support costs if we were to release a software that has a lot of bugs. However, code UI testing also presents some challenges. One of the main challenges is the time and resource required to conduct a thorough testing. User interface testing can be time consuming and requires a significant amount of manual effort. This can be challenging, particularly for applications with complex user interfaces. Another challenge is ensuring that the test cases cover all the possible interactions. This can be challenging, particularly for applications with high degree of complexity. Additionally, automated testing can sometimes generate false positives or negatives, which can be time-consuming to debug and fix. We have to keep in mind that we already have a lot on our plate when we are developing a software. We have to make sure that the code doesn't have any bugs. We are following the best practices. We are meeting the requirements specified by the client and everything. when we are introducing automated UI testing, we are already putting more effort into setting up the automated tests. Now, if we have to debug the automated tests on top of that, it actually adds a lot on our adds a lot on our costs and uses a lot of our resources. So that is something we also have to keep in mind. Overall, code UI testing is a crucial part of a software development because without proper testing, releasing a software in the market to the client is a very risky game because in today's world, softwares are being used in crucial cases. A small bug in the software can become a threat to a human life. So by testing the user interface, developers can identify issues and ensure that their application functions correctly. Both manual and automated testings have their benefits and challenges, and it's up to the development team to decide which method is best for their application. Now I will pass it on to my friend Bunyod to talk about the detailed benefits of coded UI testing. Thank you.
All right, thanks so much. My name is Bunyod, and in this slide, we'll be talking about the benefits of coded UI testing. So as you can see on the screen, there are four main benefits of coded UI testing. They are faster and more reliable testing, increased test coverage, early detection of defects, and reduced costs and time to market. Okay, let's talk about each in detail, okay? So coded UI testing allows for automated testing of user interfaces, which can be faster and more reliable than manual testing. Coded UI tests can be run repeatedly and consistently without human error, and they can run much faster than a manual tester could complete the same tests. This can help to speed up the testing process and make it more reliable, ensuring that issues are caught and fixed before they can affect the end users. Coded UI testing can help to increase test coverage as well by allowing for the testing of a wide range of scenarios and use cases. And automated tests can be run on a variety of devices, operating systems and browsers, and it can simulate different user interactions with the application. This means that more tests can be run in less time and that a wider range of scenarios can be covered, helping to ensure that the application is thoroughly tested. When it comes to early detection of defects, coded UI testing can help to detect defects early in development cycle before they can become more serious or impact end users. Automated tests can be run continuously throughout the development process, catching issues as they arise and allowing for faster resolution. This means that it can help to reduce the time and cost associated with fixing defects, as well as improve the overall quality of the application. And last but not least, coded UI testing can help to reduce costs and time to market by streamlining the testing process and catching issues early. By automating testing, developers and testers can work more efficiently and issues can be addressed quickly before they can become more complex and or expensive to fix, okay? So these can help to speed up the development process and reduce the time and cost associated with testing, allowing products to be brought to market more quickly and a lower cost. All right, so these were the four main benefits of coded UI testing. As we move on to the next, slide, we're going to talk about the types of coded UI testing, and we're going to discuss five different types of coded UI testing. So we have functional testing, regression testing, cross-browser testing, localization testing, and performance testing. All right, let's talk about each in more depth. The first one is functional testing. So functional testing is the process of testing an application's functionality to ensure that it meets the specified requirements. This type of testing verifies that the application behaves correctly when users interact with it. In coded UI testing, functional tests are automated to save time and improve accuracy. Coded UI tests can simulate user interactions with the application to ensure that it performs as expected. When it comes to regression testing, is the process of testing an application after changes have been made to ensure that the changes did not introduce any new bugs or regressions. Okay, it's very simple. And this type of testing is critical to ensure that the application remains stable and functional. In coded UI testing, regression tests can be automated to save time and ensure that all tests are run consistently and accurately. The next one is cross-browser testing, which can be defined as the process of testing an application across multiple browsers to ensure that it functions correctly on all supported platforms, okay? And this kind of testing is critical to ensure that the users can access and use the application regardless of the browser they are using. In coded UI testing, cross-browser tests can be automated to ensure that the application functions correctly on all supported browsers. And we have localization testing. As the name suggests, it's kind of testing an application that ensures that it functions correctly in different
Hello class, my name is Eric Morgan, and I'll be covering my part of the Coded UI lecture, Automated UI Testing. So, what is automated UI testing? First, I'd like to define user interface, or UI, and UI testing. So, a UI, or user interface, is the front end of an application that facilitates interaction with users on their screens. So this could be a laptop, a phone, a tablet, etc. And UI testing is the process used to verify whether the end user interface is running correctly, making sure buttons and other parts of the screen are working as usual, as working as intended. So automated UI testing, to define that, it is a technique in which testing processes are performed by using an automation tool. So instead of having testers click through the application to verify data and action flows visually, test scripts or little code snippets are written for each test case. This is a series of steps to follow when the verifying data is then added. This simplifies the process of creating tests and getting results. So an example of this would be that you have a box that holds a number and it has a set. So let's say that set as a double of 10,000, 10,000.00. And so we have another set holding a double. We call this the interest, and it's a rate of 7.5%. And we have a button to calculate your interest each time we click. So it's a click event. So we have an if statement saying if the numbox total dot get value. So once we calculate this value, if it does not equal 10,750, then we report it as an error. And so this is a little script that we can write to automate the process of testing this part of the software. So why use automated UI testing? What exactly do developers get out of it? So it's chosen for several reasons. A lot of these reasons are against the use of manual testing, or just having someone sit at a computer desk and just manually go through each possible test case. So one of the reasons we do this is that it saves time. So manual testing is slow and cannot keep pace with many developmental processes. It lowers costs. Manual tests are resource intensive and costly, but there's a catch, however, with automated UI testing, that there's a big cost at the front, but then later down the road, this high cost won't matter because we've saved a lot of money in the end without having to do a bunch of manual tests. So we just need to adjust our budget to make sure we can afford it at the start of our development process and then be able to afford it later on down the road. It's more accurate. So for accuracy, manual tests are prone to more errors when performing repetitive tasks. This is human error. So automation reduces the chances of these human errors occurring. It lowers scale. It is difficult to rely on manual tests when performing complex iterations, so we can lower the scale of a project by just having the UI go through it. And trend setting, or just having a trend. We've noticed that there's a trend in automated UI testing. It seems to be a bit of a bandwagon, and other companies are pursuing it. So we see that there's obviously some kind of benefit to using automated UI testing. Disadvantages of automated UI testing, and this is compared to manual testing, like I said before. There's a high upfront cost, like I've explained. There's a big cost hump at the beginning, but as long as we can afford that in our budget whenever we want to use it, we should be fine later down the road because we don't have to spend so much money performing repetitive tasks over and over and over again. Maintenance issues. It can get a bit tedious to run tests. Test maintenance can become tedious whenever we're doing automated UI testing. And there's a greater learning curve. So some of the way these things work with automated UI testing, it can be kind of hard to understand at first, but once you get it, you have an automated system to take care of tests at a lot faster rate. When do we use automated testing? So as the saying goes, there's a time and a place for everything. So we can use it with tasks get repetitive. We don't have to have someone sit there and put through tests that are basically the same thing over and over again. We can have the computer go through it a whole lot faster. Integration of UI tests into the development process. We can go ahead and just decide to use it at the beginning whenever we want to integrate UI tests. And whenever we're testing the UI load and performance. So the user interface, that's a part of your screen, all the buttons in your search engine that you have attached to it, all the times you have to click through it, that all puts a memory load on our machines and can lower performance. And performing tests between platforms, so it's like connecting a Linux platform to a Mac or a Linux to a Windows machine, so on and so forth. And our last bit here for
Thank you. My name is Joshua Shearer, and I will be presenting the part of the challenges of UI testing. As with anything related to software or computer science in general, there's always going to be another issue. There's always going to be another problem. For us, however, simply for the sake of time, I will discuss 3 of the main issues that can arise that can cause problems to occur for automated UI testing. First one being the increase of maintenance and management, followed by environment compatibility, and finishing with execution time and resource consumption. Maintenance and management. With this, we are asking the question, how much overseeing is needed? How much does the tester need to interact with this supposedly automatic testing tool. Automated UI testing will always need to have some form of human interaction, because although it is automated, somebody still needs to push the start button. Somebody still needs to make sure that it's lined up properly. Someone needs to do the initial set of keystrokes and mouse movements in order for the tool to be able to replicate those movements. As the project increases, so too does the complexity of the tool. For example, suppose at the beginning of your project's life cycle, you only have 3 working functions that need to be tested prior to the next phase. An automated UI testing tool would run through those 3 functions, and that would be fine. However, say in the next 3 phases, you add another 15 or 16 functions that need to be tested, as well as the original 3 functions to ensure that there were no errors created in the new functions that link to the old ones. Now, the automated UI tester needs to be reprogrammed or reset in order to handle the new functions. Otherwise, it will simply keep testing just the old functions, and the new functions will still be technically considered unfinished. Next, we discuss environment compatibility. A common thing heard amongst software developers when being told that their software does not work for a client or another developer is the common phrase of, well, it works on my machine. The idea behind this is that even though code is created on one platform or in one IDE, that's not necessarily how it will run on another user's computer. An example of this is the case of earlier in the lecture we mentioned several tools that are used for the automated UI testing capabilities. However, there are some IDEs that do support plugins that have their own designated plugin for an automated UI tester, such as Microsoft Visual Studio. However, not all IDEs have those, meaning one developer may have it, the other one may not. And even if the IDE being used has a plugin for it, again, as with all software, there will always be another issue. There may be bugs that arise simply due to differences of operating systems or versions of operating systems, or even so simple as just a random particle from space causing a problem in the computer. And lastly, we bring up the largest issue: the execution time and resource consumption. As mentioned with maintenance, as the project becomes more complex, the number of resources needed increases as well. For example, back to the original project. If you are only testing for 3 functions, the number of commands needing to be stored and performed stay relatively small, or at least the size for those 3 functions. However, after you add those other 15, 16 functions, your computer will need to utilize more memory to remember the functions, to perform them, until eventually you may end up running into an error where your computer just can't run both the program and the UI tester at the same time. A large example of this is a form of UI testing known as load testing. Similar to what most people would assume for UI testing, of pushing a button, entering some numbers on the keyboard, and hitting enter, and doing it, say, 1,000 times. Load testing is used more to find the breaking point of programs. Common idea is finding the maximum number of users allowed to be on a specific server prior to server being overloaded. Load testing would take and log in and perform actions and then stay before opening up another instance of itself, performing those same actions until eventually the server decides that it's had enough. The problem that can arise from this, however, is that your computer may not be as strong as the server. The server may take upwards of 130,000, 200,000 even users, but your computer may only handle having maybe 50 instances of the UI tester open before you've used all of the possible memory in your machine. This causes an issue because on your end, you see that it stops at 50, but the actual limit is much, much higher than that, indicating that the resources being used that are needed to properly perform the UI test just simply aren't there. And the main idea to keep in mind is that performing tests consecutively takes time. If there are 100,000 tests needed to be done, and each test takes about 5 seconds to do, that's still 500,000 seconds, which roughly, going for how much sheer time this would take, is comparable to over 130 hours. This doesn't seem like much for a machine to do. However, when comparing this to how much oversight is needed, someone needs to check in on the machine every so often for the entire 5 to 6 days straight that it is running to ensure that some error does not occur, to ensure that it didn't overload itself, or to ensure that simply it just didn't have an internal error and misclick, and it hasn't been performing the proper test for the last 3 days. Keeping this in mind, UI testing can still be considered a very, very useful tool, simply for the fact that it removes the need for people to enter the tests themselves until the system breaks. I mean, again, off the previous example, Most people that I know could not handle sitting down for 140 hours doing the same keystrokes, the same mouse movements, day in and day out. If the machine ran straight and assuming no errors occurred, it would run for almost 6 days. However, if a person were to do it, and we say they work a 12-hour day, that would take them nearly 2 weeks to do. Almost 3 times the amount of time it would take the machine to do it. Keeping that in mind, it is a useful tool, though only for the monotonous parts. We would like to thank you for your time, and we hope that our presentation informed you of this topic, and that you may have learned something that you yourself may not have known originally. Thank you.